Okay, so in this particular case, what we've got is a hydrated sample of sodium thiosulfate, right? And the mass of the hydrated sample has been found to be 11.44 grams, and a hydro sample has been found that the mass is 5.68 grams, and so we need to effectively use this information to work out the value of x, with x being the coefficient associated with the H2O in this particular formula, right? So one of the first things I'm going to do is consider the fact that when it comes to trying to work out the value of x, what we really want to do is molar related comparisons. We want to say, well, for every 1 mole of Na₂S₂O₃, how many moles of H2O? But before we could even get into that kind of conversation of trying to make that, try and do that analysis, we need to get the information we have, which is not in moles, it is in masses. We need to get that into a formula. We need to get that into a format where we can actually make molar comparisons, right? So the first thing I'm going to do is I'm going to look into, well, what's the number of moles of sodium thiosulfate, and I'm going to be using the formula that the number of moles N is equal to the mass divided by the molar mass MR, right? So for Na₂S₂O₃, so if I say the number of moles of Na₂S₂O₃ is equal to, so it's mass divided by molar mass. Now the mass that's relevant here is really the 5.68, right? So it's going to be 5.68 grams, right? But then I need to also calculate the molar mass, and I don't have that value, right? But I do have the formula, right? So Na₂S₂O₃, right? So we're looking for the MR of this formula. So what are the relevant elements? Sodium, right? So Na, right? And then S2, so sulfur is relevant, and then oxygen, right? Okay. And so adding up the relevant relative atomic masses with the, given, and considering also factoring in the frequency that they occur in the formula, that's going to be 23 times 2, right? So Na2 plus, for the sulfur, it's going to be 32.1 times 2, and for oxygen, that's going to be 16 times 3, right? And so that's going to give us our molar mass for this, and that's going to be 150. It's going to be 158.2, right? And that's going to be in units of grams per mole, right? So we've got 158.2. And if we work this out here, this is going to give us 0.035904, right? And that's going to be in moles, okay? Now, when we look at the, so we've done that component. What we also need to do though is we need to work out the number of moles for the H2O, right? So the number of moles for the H2O is going to be equal to what? It's going to be equal to the mass. So do we have the mass? No, the mass isn't exactly given in the question, at least not directly, but arithmetically we can work out the mass. So if we've got a hydrated sample and then we've got an anhydrated sample, the difference between those values is really going to give us the mass of the H2O that was present in the hydrated sample. So effectively, the mass for H2O is going to be, in this particular case, 11.44 minus 5.68, right? And that's going to give you 5.76, and that's going to be in grams. And so when it comes to working out the moles of H2O, of course it's mass divided by molar mass, so it's going to be 5.76 divided by the molar mass for H2O. So let's work out what the molar mass for H2O is, right? So mR for H2O, right? What's that going to be? Well, you've got H2 first of all, so the relative atomic mass for the hydrogen is going to be, you know, the 1 times 2. That's going to give us the hydrogen's contribution, right? So H2. And you need to factor in the relative atomic mass of the oxygen, so that's going to be just plus, because it only goes once, it's just going to be plus 16. So that's going to give us 18, right? And the units of that is going to be in grams per mole, right? So the 5.76 divided by 18, right? And so what's that going to give us? So if you work that out, that's going to give you 0.32, right? And that's going to be in moles. So now we've got the moles for the Na₂S₂O₃, and we've also got the moles for the H2O. Now, what I want to do is I really want to compare these two values, and this is going to help us to figure out the answers to that whole question. So if we consider, well, this is on the left hand side, H2O is on the right hand side, so I'm going to set up the comparison in a similar way, in the sense that Na₂S₂O₃ is going to be on the left hand side. So number of moles of Na₂S₂O₃ compared to number of moles of H2O. Right, so we've got the Na₂S₂O₃ value here, so that's going to be 0.035904 compared to the value for the H2O, so that's going to be 0.32. Right. Now going back to the central question, really the question we're asking ourselves is, for every 1 mole of Na₂S₂O₃, how many moles of H2O? Right. So if we're making that comparison, it is really a question that relates back to amounts of substance and relates back to effectively moles, right? So in this case, if we want to get that, what we want to do is get this value to 1, right? So, and how do we do that? Well, the straightforward way to do it is to divide it by itself, right? So if we divide this by 0.035904, we're going to get 1. Now on the other side of the equation, we're going to divide this by the same, so 0.035904, right? And if we do that, we're going to get 8.9127, right? And what we're going to want to do is we're going to want to round this to the nearest whole number, specifically because x, what we're really looking for in terms of x is we're looking for an integer value, right? So in fact, what we're going to say here is, well, 1, and that's going to be in comparison to what is approximately 9, right? So because we're going to have to round this up to 9, so, and therefore we're going to say that x is equal to 9, right? Now because x is equal to 9, our formula is effectively going to be what? It's going to be Na₂S₂O₃ and then dot 9 H2O, right? So in this particular case up here, where it says enter your answer in the space provided, what we're going to have is a 9, okay? All right.